Hello class. Right now I am going to demonstrate how to test a correlation by hand. If you want to follow along with the problem, you can find it on page 176 of your textbook. It is problem number 55. To do a correlation, you need to have two sets of scores such that everything is paired up. I have two sets of 7 scores here, so I have 7 sets of scores. First, you want to pick one of the variables to call x and the other one to call y. It doesn't matter which one you pick. Step 1 to test a correlation is to make an x-y column. In the xy column, you multiply each x value by its paired y value. You multiply the values all the way down the column. I'm going to use an on-screen calculator here. Step 2 is to find the sum of column x, the sum of x squared, the sum of column y, the sum of y squared, the sum of xy, and n. To find the sum of x and the sum of x squared, enter the values for x into your statistics calculator. Once you have those two values, you can repeat it with the values for y. Next, get the sum for the column xy. Next, you'll need n. For a correlation, n is the number of pairs of scores. In this case, n is equal to 7 because I have 7 pairs of scores. Next, you want to find r. On the screen here, I have put the formula for r, and you can also find it on page 124 of your stats book. A common mistake that people make with this formula is that they forget to take the square root. Don't let this happen to you. After solving for r, I've gotten a value of 0.96. Remember, your value for r should always be between -1 and +1. If you get a value outside of that range, something has gone wrong, and you need to check your math. It can be positive or negative, which is important for writing your conclusion because that tells us the direction of the effect. Next, you want to find t. The formula for t is on the screen, or else you can find it on page 124 of your stats book. This formula has a square root in both the numerator and the denominator, so be sure to pay attention to both. After solving for t, I've gotten a value of about 7.67. I got a positive value for t obtained, but if you do get a negative value for t obtained, make sure that you drop the negative before comparing it to t crit. Next, find the degrees of freedom. The formula for this is n minus 2. So in this case, the degrees of freedom is 7 minus 2, which is 5. Next, look up the value you got for your degrees of freedom in the t-table on page 258 of your book. In this case, a degrees of freedom value of 5 corresponds to a t-crit value of 2.571 at an alpha level of 0.05. So my t-crit value is 2.571. Next, compare your t obtained value to your t crit value. In my case, my t obtained value is greater than my t crit value. And when your t obtained value is greater than your crit value, that means that you've found a reliable correlation. If t obtained is not bigger than t crit, you have not found a reliable relationship. Finally, we can write our conclusion. Because our t obtained is greater than our t crit, we have a reliable relationship. Because the value for r is positive, that means we have a positive relationship between x and y. So our conclusion is that the data show a reliable, positive relationship between the amount of alcohol consumed and hours of sleep. We know it's a reliable relationship because our t obtained value is greater than our t crit value, and we know that it's a positive relationship because our r value is greater than 0. If the value for r was negative, then that would have told us that there was a negative relationship. When we have a positive relationship, that means that when the value for x increases, the more alcohol you consume, the value for y also tends to increase, the more hours of sleep you get. In contrast, for a negative correlation, when x increases, you expect y to decrease, which is whenever you have a negative value for r. That concludes the demonstration on how to test a correlation.